Let's zoom in our space binoculars and take a peek at baby galaxies forming. Whoa, surprise alert! We're spotting galaxies from way back in the ancient days of the universe. For a long time, scientists believed in the Big Bang theory to explain how everything started. Lots of smart folks worked together doing tons of research to back up this idea, but science keeps changing, you know? New gadgets and gizmos give us fresh ideas about how things began. And in this ever-changing world of science, one guy stands out: Neil deGrasse Tyson. Now, a groundbreaking development has come to light as the James Webb Space Telescope has unveiled a revelation that calls into question the long-standing Big Bang theory. This discovery involves the detection of a staggering 750 new galaxies, each of which defies our previous expectations of what galaxies should be like. By the way, the James Webb Space Telescope was conceived and designed to help us understand the origin of galaxies, so we shouldn't be surprised that it's forcing us to scratch our heads. Join us as we explore how the new images from the JWST debunk the Big Bang theory with the discovery of 750 new galaxies. Scientists have put forward the Big Bang theory as the leading explanation for the origins of our vast universe. According to this theory, around 14 billion years ago, the universe came into existence through some sort of mysterious cosmic event. It's the ultimate birth story of the cosmos. The surprising nature of the images captured by the James Webb Space Telescope has challenged scientists' understanding of the universe's origins. The hypothesis that these images directly contradict is the Big Bang hypothesis, which has long been regarded as an unquestionable truth by the majority of cosmological theorists. These galaxies appear to be too small, too smooth, too old, and too numerous when compared to the expectations of the Big Bang hypothesis. The small size of the observed galaxies entirely contradicts the expected behavior in an expanding universe. According to the hypothesis, as the universe expands, objects should appear larger with increasing distance. According to the Big Bang theory, at the very beginning of the universe, all matter, energy, and the building blocks of the cosmos were compressed into an extremely tiny and highly concentrated point. This point is called a singularity. This is a point where infinite density exists. When we say infinite density, we mean that the matter and energy within this singularity were squeezed together to such an extent that their density reached an infinitely high value. The concept of a singularity comes from our current understanding of the laws of physics, particularly the equations of general relativity proposed by Albert Einstein. Within the singularity, all the matter and energy in the universe existed in an extraordinarily compressed form. The extreme density implies that an enormous amount of mass and energy was concentrated within an infinitesimally small space. While the space isn't much of a problem here, when there's so much pressure and density, you've got unimaginable heat. The temperature within the singularity would exceed any temperature that can be observed or reproduced in our current understanding of the universe. The energy stored within this hot, dense point was the seed from which the entire universe would unfold. That's why the singularity marked the beginning of the universe as we know it. It was the origin from which everything in our cosmos came. After the initial singularity, the universe started the journey of expansion and inflation. This process occurred over the course of approximately 13.7 billion years, shaping the universe as we know it today. The expansion of the universe started with an extraordinary burst of rapid expansion known as cosmic inflation. During this phase, the universe expanded at an unimaginable rate, far exceeding the speed of light. It's like the fabric of space itself was stretching and stretching, taking everything within it along for the ride. Cosmic inflation played a massive role in shaping the large-scale structure of the universe. It smoothed out irregularities, homogenized the distribution of matter and energy, and set the stage for the subsequent formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of expansion gradually slowed down. But with this information, it's important to note that even though the initial period of cosmic inflation ended, the universe continued to expand at a measurable rate. This ongoing expansion is known as the expansion of the universe or cosmic expansion. Scientists have observed the effects of this expansion through various observations, such as the redshift of light from distant galaxies. The redshift indicates that as the universe expands, light waves get stretched and shift towards longer wavelengths, shifting them towards the red end of the spectrum. We'll get into the details of this later on in the video. At first glance, the images of the new galaxies taken by the JWST look absolutely breathtaking in a good way. You can see hundreds of galaxies all in the same frame, and the sheer power in the photos is something you just can't ignore. But that's what things look like to the average person. For researchers, things are the total opposite. These pictures are surprising, to say the least. They don't match what scientists thought they would see based on their theories. In fact, they're seeing way more galaxies than expected, and these galaxies are different in some surprising ways. They're smooth, smaller than imagined, and really old. All these surprises are causing a bit of a panic among the scientists. One paper even starts with the word panic in its title, so you know things are serious. The galaxies look nothing like what they're supposed to. The age of the observed galaxies seems to be incredibly strange here. The JWST observations indicate the presence of galaxies that appear to be unexpectedly old. This challenges the expected timeline of galaxy formation and evolution within the framework of the Big Bang theory. Plus, there's also the fact that the abundance of observed galaxies is a lot higher than what it was supposed to be. The Big Bang hypothesis predicts a certain distribution and density of galaxies based on the expansion and evolution of the universe, but the JWST images show a massive number of galaxies, which raises questions about the accuracy of the predictions made by the hypothesis. There's also the fact that the smoothness of these galaxies is totally unexpected. The Big Bang theory suggests that galaxies should exhibit irregularities and variations in their structures due to the dynamics of their formation and evolution. However, the JWST images reveal galaxies that appear unusually smooth, lacking the expected level of complexity and roughness, which is what you'd normally expect to see in the images according to the Big Bang nucleosynthesis theory. While the expansion was happening, we basically had all the stuff that makes up our universe squeezed into an incredibly small volume. It was clear that matter could not survive in space like this, so something had to give. As the universe expanded and cooled down, transformations took place. Particles such as protons, neutrons, and electrons began to interact with light and energy in their surroundings. These interactions played a pivotal role in shaping the formation of matter in the universe. During the first few minutes after the Big Bang, there was a process called nucleosynthesis. This process involved the creation of lightweight elements like hydrogen and helium. The extreme temperatures and conditions during this phase allowed for the fusion of protons and neutrons to form these simple atomic building blocks. Hydrogen, the simplest and most abundant element in the universe, was formed primarily during this early period. Helium, the second most abundant element, also emerged during this time. These elements were instrumental in setting the stage for the formation of stars, galaxies, and more complex elements that would come later in cosmic history. The synthesis of these elemental building blocks was a significant milestone in the evolution of the universe. From a primordial sea of particles and energy, the early universe transitioned into a state where matter actually began to take shape. This process was what laid the foundation for the rich diversity of matter and the vast cosmic structures that eventually came into being. Theorists had anticipated observing galaxies mangled and scrambled due to multiple collisions. However, the JWST images tell a different story. Instead of chaotic and disheveled galaxies, The images reveal overwhelmingly smooth disks and well-organized spiral forms resembling the galaxies we see in the present-day universe. This unexpected observation challenges the notion that mergers are a common process in the evolution of galaxies. Neil deGrasse Tyson. Big Bang debunked. James Webb detects 750 galaxies outside the universe. This observed, large-scale structure aligns with the predictions made by the Big Bang theory. According to the theory, the universe began as an incredibly dense and hot state, and over time expanded and cooled. As the universe expanded, gravity played a pivotal role in shaping the distribution of matter and the formation of galaxies. The gravitational effects predicted by the Big Bang theory are consistent with what we observe today. Gravity draws matter together, causing galaxies to cluster in certain regions and form intricate filamentary structures that connect them. These structures reveal the cosmic web-like pattern of the universe. The presence of these galaxy clusters and the interconnected web of matter provide strong support for the Big Bang theory. The formation of galaxies and their distribution across the universe aligns with the gravitational effects expected from the initial dense and expanding state posited by the theory. When you take another look at the size of the galaxies the James Webb Telescope found, you can really see how the images portray a completely opposite reality to what we've always thought was our reality. According to Big Bang theorists, these tiny galaxies grow and evolve into the larger galaxies we observe today through a process of collisions and mergers. To make it easier to think about this hypothetical scenario, you can think about the individual galaxies as a magical toy car, one that starts as a centimeter-long vehicle but grows into a full-size SUV by colliding with numerous other toy cars, gaining size as it goes. However, the observations made by the James Webb Space Telescope have cast doubt on this proposed merger process. If we were to believe the toy car analogy, one would expect to see at least some evidence of collisions or dents in the interacting galaxies. But the expansion eventually slows down and reverses direction due to the force of gravity exerted by the matter and energy in the universe. As the expansion slows down, the universe enters a phase of contraction known as the Big Crunch. During this phase, the universe becomes increasingly compressed and denser, leading to a highly compact state. Eventually, all matter and energy in the universe are concentrated into a singularity, a point of infinite density and temperature. In a way, this could explain the new galaxies that have been detected. Maybe they were part of a new cycle that we just happened to catch. Could this be the indefinite proof we needed to debunk the Big Bang theory? These are all fascinating theories that challenge our understanding of the universe and its origins. As we continue to explore and study the cosmos, we may uncover even more evidence that sheds light on the true nature of our universe and how it came to be. Subscribe for more.